A very good morning to all of you. I cordially welcome you all for this applied thermodynamics course. So today we are going to discuss about the important class, that is the CDT number 1. That is how can we find out the steam properties. That is a very important one. So here in the today's class, what is the motivation to study this important topic, that is the steam properties? So it is very essential to know the steam properties to assess the quality of the steam which is leaving the boiler. And the outcome I'm expecting from this particular lecture is you should be in a position to define the properties of the steam under the given conditions. So what are the various properties of the steam, or what are the various types of the steam? There are three types of the steams are there. The first one is known as the wet steam. So whenever a steam is basically lying in this particular the water steam region, that is nothing but is a liquid plus is a vapor region. So then it is known as a wet steam. So it is known as the wet steam. And whenever a steam is lying on this line is basically known as the dry steam line, that is the saturated vapor line. So whenever it is falling on this particular line, then it is known as the saturated vapor line. And whenever it is further superheated, then automatically this entire region is known as a superheated region. Then it is known as the superheated steam. And here it is the dry saturated steam, and it is the wet steam. And this is known as the saturated liquid line, and this is known as the subcooled region, or it is the water region. And this is known as the critical point. So this critical point is basically separating the saturated liquid line as well as the saturated vapor line. The important questions are nothing but just to observe on the y-axis we are having the temperature, on the x-axis we are having the latent heat of the vaporization. That is, the total heat is basically classified into the two types. One thing is known as the sensible heat, and the second one is known as the latent heat. Now just to observe here, the area is very large between the saturated liquid line and the saturated vapor line whenever the pressure or temperature values are very low. And whenever the pressure or temperature values are increasing, just you are able to observe the area is gradually diminishing, and the area will be equivalent to 0 whenever it reaches the peak point, that is known as the critical point. So the pressure and the temperature corresponding to this particular critical point is known as the critical temperature, which is denoted by Tc, and similarly the critical pressure is denoted by a Pc. So like that we are able to represent the critical pressure as well as the critical temperature at the critical point. And at this particular critical point, you are able to say that the HFG value, it is always equivalent to 0, because here the HFG value is gradually decreasing and its value will be equivalent to 0 at the critical point. So the same thing I am able to explain the same concepts through this particular slide, whatever I have written in the previous slide. So the important one is, for steam, what is the value of the critical temperature? So it is always equivalent to 374.15 degrees centigrade, and the critical pressure value is always equivalent to 221.2 bar. So these are the critical pressure and the critical temperature of the steam. So I've already told you that the three types of the steams we are able to have. One thing is known as the wet steam. So whenever the steam is falling in the liquid plus vapor region, it is known as the wet steam. And whenever the liquid is further heated, then automatically it will be converted, or it will fall on the saturated vapor line, that is the dry saturated steam. And whenever the dry saturated steam is further heated at constant pressure condition according to the sensible heat transfer, then we are able to have the superheated steam. So these are the three different types of the steam. So wet steam, dry steam, as well as the superheated steam. The another important formula here is the dryness fraction of the steam. How can we define the dryness fraction of the steam, or how can we find out the dryness fraction of the steam? Here G stands for vapor, F stands for the liquid. So the dryness fraction of the steam is basically defined as the ratio of mass of the dry steam to the total mass of the steam. So the total mass of the steam is nothing but mass of the dry steam plus mass of the liquid steam. So X is equivalent to mg by m. So X value is normally equivalent to 0 to 1. So 0, it is nothing but is on the saturated liquid line, and 1 is on the saturated vapor line. So for the dry saturated steam, X value is always equivalent to 1, and for the wet steam we are able to have the various values of the X which are lying in between the 0 to 1. So if he said that in the examination he says that the steam is 90% dry, that indicates that mg value as given as the 0.9. So the total mass of the steam is equivalent to 100%, that is equivalent to 1. So we are able to say that the dryness fraction of the steam is equivalent to 0.9, that is nothing but it's a 90% dry. That is the meaning of the dryness fraction of the steam. So we are able to see what is the definition of the dryness fraction of the steam and what we mean by mg and mf like this. And I told you that the heat is basically classified into the two types. One is known as the sensible heat and the second one is known as the latent heat. So what is the formula to find out the sensible heat transfer? Qs is always equivalent to mcp into delta T. So for unit mass of the substance, m value will be taken as 1 kg. And always you have to remember the specific heat of the water, it is always equivalent to 4.18, but all our practical calculation purpose we are taking it as a 4.2 kilojoules per kg Kelvin, and the delta T, it is nothing but the final temperature minus initial temperature difference. Like this we are able to find out the sensible heat. And the next one is known as the latent heat. The latent heat of the steam is nothing but 2257 kilojoules per kg for the water or for the steam. So what is the meaning? That is, if you want to convert 1 kg of the water into 1 kg of the steam, how much amount of the heat input you required? That is equivalent to 2257 kilojoules amount of the heat is required to convert 1 kg of the water into 1 kg of the steam. Or similarly, vice versa, if you want to condense 1 kg of the steam into the 1 kg of the water, then this much amount of the heat is to be extracted from the vapor so that it will be converted into the liquid. So that is the meaning of the latent heat of the vaporization. And I've already told you that the total heat is always equivalent to the summation of the sensible heat as well as the latent heat. So here, the important one is how can we calculate the important three properties, that is the enthalpy, specific value as well as the entropy for wet steam, dry steam as well as for the superheated steam. So that is the gist of this particular lecture. So that is, we know that there are three types of the steams are there: wet steam, dry steam as well as the superheated steam. So the three important properties are specific enthalpy, specific entropy and specific value. So how can we find out these three important properties for the various types of the steam numerically? So that is the gist of this today's lecture of CDT number 1. So for wet steam, we can find out the enthalpy formula is equivalent to HF plus X into HFG, where X is equivalent to dryness fraction of the steam, where HF is equivalent to enthalpy of the liquid and HFG is equivalent to latent heat of the vaporization. HFG value here you can see it is always equivalent to Hg minus Hf. And for the dry steam, I've already told you that X value is equivalent to 1. So whenever you are substituting X value is equivalent to 1, the same formula will be modified into HF plus HFG, which is nothing but Hg value. And similarly for the superheated steam, how can we find out the enthalpy? So always the superheated steam is basically behaving like the perfect gas. So here you can see Hg stands for the enthalpy of the dry saturated steam. So how much you are further superheated. So I already told you that the further superheating is always taking place according to the sensible heat transfer. So per unit mass of the substance, sensible heat transfer is nothing but Cp into delta T. The same formula I have written here, Cp into delta T, that is the T superheated minus is the T saturated. So this is known as the degree of superheat. And Cp value of the superheated steam always will be in the range of 1.67 to 2.5 kilojoules per kg Kelvin. If the Cp value is not given in the problem, so you may take any value which is lying in between 1.67 to 2.5 kilojoules per kg Kelvin. So for wet steam, how can we find out the specific value? So the basic formula is xVg plus 1 minus x into Vf, but the specific volume of the liquid is very, very small compared to the specific volume of the vapor. So because of this, the 1 minus x into Vf this can be neglected, so that simply we can write down the specific value of the wet steam will be equal to x into Vg. And I already told you that for the dry steam, x value will be equal to 1. So 1 into Vg is nothing but Vg. And for the superheated steam, how can we find out? Just now I told you that always the superheated steam is basically behaving like the perfect gas. So you may apply the ideal gas laws. So one of the laws is Charles' law. So Charles' law says that whenever the pressure is constant, we can say that volume is directly proportional to temperature. So you can apply this particular law to the superheated steam as well as to the dry saturated steam, so that V superheated by T superheated is equivalent to V saturated by T saturated. From this we are able to find out what is the formula of V superheated steam. So the next one is the entropy. So it is also exactly the similar lines of the enthalpy. So we told you that H is normally HF plus X into HFG. So in the similar lines for the wet steam, the entropy is nothing but SF plus X into HFG. It is the formula for the entropy of the wet steam. And for the dry steam, X value will be equivalent to 1. So SF plus SFG, that is equivalent to SG. And superheated steam, I've already told you that it is nothing but Sg plus the sensible heat transfer, that is nothing but Qs. So Qs is nothing but the Cp into delta T. So entropy is nothing but the ds value is nothing but delta Q by T. So this is divided by T. So Cp into delta T by T, that is nothing but Cp into log T2 by T1. So Sg plus Cp log T superheated by T saturated, that is a formula for the superheated steam entropy value. So now with this particular the concept, now you should be in a position to answer some important questions which are given in previous GATE and IES examinations. So the first question is, with the increase of the pressure, the latent heat of the steam. So in the first graph I told you that the latent heat of the steam is basically decreases with increase of the pressure and increase of the temperature. So the answer is C. So the second question is, at a critical point, what is the latent heat of the vaporization value? I told you that its value is equivalent to 0 at the critical point. So the answer is equivalent to 0. So the next question is, the total mass of 1 kg of the working fluid, 70% is a dry steam. Now what is the dryness fraction of the steam? Now always I am saying you, always the questions will be asked only on the higher order cognitive levels. So on the definition of the dryness fraction of the steam, now you have to answer this particular question. So X is equivalent to mg by m. So where mg is given as a 0.7 by 1, so automatically the dryness fraction value will be equivalent to 0.7. So the answer will be equivalent to 0.7. So the next question is basically given on the degree of the superheat formula, because you know that the degree of the superheat formula is nothing but is a T superheated minus is a T saturated. So here the T saturated is given as the 70 degrees centigrade and it is superheated by 5 degrees centigrade. So the T superheated value is given as 75 degrees centigrade. So automatically it will be equivalent to 75 minus 70. So the answer will be equivalent to 5 degrees centigrade. So like that, you should be in a position to answer some of the important questions which are given on this particular important topic. And what are the advantages of the superheating steam? So please go through the 5 important points of the advantages. So it is a very, very important class. That is, what are the various types of the steam? That is the wet steam, dry steam, superheated steam. And how can we find out the properties, that is importantly specific volume, specific enthalpy and specific entropy for the wet steam, dry steam and the superheated steam. So these are the concepts we covered in this important first class of the CDT1. So thank you one and all for listening this important class on the steam properties. Thank you.